In this video, I will explain how to get different types of images by using concave and convex mirror. And to get the image from the mirrors, uh, uh, we have the light, means light rays should fall on the mirrors. For example, if the source of an object is very far, like sun, if the source of light is very far, then how does the reflection takes place by these mirrors? If you take a convex or concave mirror, when the source of light is very far, we get the light rays from that objects are parallel. That light rays are parallel. Always you will get a parallel beam of light rays when the source of light is very far. Okay. In that condition, you will get all the reflected rays, they will meet at one point. Where they are meeting, that point we'll call it as focus, whether it is a concave mirror or convex mirror. And there is a relation between that focal focus and the center of curvature. There is a relation between focus and center of curvature. See, there is a relation between, what is the relation between? I said the focus is the midpoint from the pole to the center of curvature. So the distance between pole to the focus, it is represented by the letter F. That distance, it is represented by the letter, or capital F you take, is F, focal length. We'll call it as focal length. The distance between P to F is known as focal length. If this is the midpoint, if it is F, then this distance is also F. And P to C is known as, the distance between P to C is known as radius of curvature. So that radius of curvature is equals to F plus F. That radius of curvature is represented by the letter R. So this R is equals to PF plus FC, means F plus F, or small f you can take, any you can take, then it becomes 2F. R is equals to 2F. So there is a relation between the center of curvature to the focal length. What is that relation? R is equals to 2F. Then what is F? F is equals to R by 2. So this you can use in solving the problems, either 1 mark or in bits. Now, how to draw the ray diagrams by using this convex and concave mirrors. Before going to draw this ray diagrams, first we have one lab activity. What is that lab activity? When you place a concave mirror, we have to observe the types of images and measuring the object distance and the image distance from the mirror. Means you have to take a concave mirror and you have to place it in one place, and take the source of light like a candle, and you have to place it at different places, and you observe what type of images you are getting, and the distances where you are getting the image distance, that you have to find out, and you have to note down the values in the tabular form. Once again, I am repeating, we have one lab activity. What is that lab activity? You have to observe the types of images. You have to observe the types of images, and also you have to measure the object distance and image distance. By and image distance. In this, by using the concave mirror, how to do? So take a concave mirror, and you take one draw scale. You take a scale, and at certain distance you take the source of light candle, and take a screen. Because you by using the concave mirror, always you will get the real images, means that you can catch on your screen. So here you have to take a screen as a paper, so you can get the image, the candle flame image on the paper. So you place it to that paper sheet, or paper sheet, and you find out. First you place it far and near, like this distances you change, and you observe each time what type of images you are getting. and each time you have to note down the distances, image distance and object distance. Here what is object distance? The distance between from the center of the mirror to, from the center of the mirror to, the distance between from the center of the mirror to the source of light, means where you place an object, the distance between the midpoint of the mirror or to the what is this object is known as object distance. Suppose if you get the image here at this point, then again you have to take the distance between from the mirror to the image, then this distance is known as image distance. Object distance always it is represented by u, and object image distance always represented by v. And what type of images you are getting? Enlarged images or diminished image, and inverted image or real image. So note down the values and write your conclusions. This is our lab activity. Now suppose if you want to draw the ray diagrams, how to draw the ray diagrams? Means when your light ray falls on the mirror, it reflects. When it reflects, always you have to draw a normal. So where it is always to draw the normal, it is time waste and it is a lengthy process. So to avoid this, we have some rules. So according to the laws of according to that rules, you must draw the ray diagrams. Now I will discuss these rules we have for concave mirror and convex mirror. What are the rules? For example, here I wrote here rules for the ray diagram. If a ray is parallel to the principal axis, if a ray is parallel to the principal axis, the reflected ray should pass through the focus. The reflected ray should pass through the focus. And what is the rule for second rule? When a ray is passing through the focus, the reflected ray is parallel to the principal axis. These are all for the concave mirrors. And when a light ray is passing through the center of curvature, when a light ray is passing through the center of curvature, the reflected ray should also passes through the center of curvature. So based on these three laws, you must draw the ray diagrams for concave mirrors. Understand? Now, how to draw the ray diagrams for convex mirror? Convex mirror. And same rules we have to apply for the convex mirror also. See, here this I drew here the convex mirror. Now, for the convex mirror, when a light ray is parallel to the principal axis, when a light ray is parallel to the principal axis, the reflected ray should pass through the focus. So actually the light ray should not pass through the focus. Why? Because here it was coated. So means you must represent with the dotted lines, and when these dotted lines when you extend, then you will get the reflected ray. So once again I am repeating, for the convex mirror, when your light ray is parallel to the principal axis, the reflected ray should pass through the focus. But actually it is not passing. Just you must note down with the dotted lines. Then that dotted lines you must extend. Then you will get the that line is passing through the focus. Now coming to the second one. When a light ray is passing through the focus, the reflected ray is parallel to the principal axis. So immediately you must draw like this. Passes through the principal axis. Next, third one. When a light ray is passing through the center of curvature, when a light ray is passing through the center of curvature, means here it does not go. So you must represent with the dotted lines. Then the reflected ray also should pass through the center of curvature. So like this you must draw the ray diagram. Based on this, we have to find out for this lab activity, we will find out once again by using this ray diagrams, how to draw the diagrams. For this, just for concave mirror, Just for concave mirror I am explaining. Just one example I will take and I will explain. Yeah, this is the concave mirror. Here when you place an object beyond C, when an object is placed beyond C, at C, and in between F and C, and at F, and in between P and F, we have the 5 situations. And in all these situations, how the reflected rays are meeting.